All right. Welcome everyone to this session. Happy to have you here. Uh, and I'm happy to introduce Talex Maxim, and I will hand it over to her to introduce her topic.
Yeah, hi guys. So happy to be here, and thank you, Zach, for walking me through introduction. So my topic will be today Chagu graph-based defense for AI system. And I would like to show you how we are using Neo4j to trace, detect, and defend generative AI workflows. Basically, for our session, I prepared rough estimation of the time. So we have 10 minutes talking about the problem and how we solve it within Chagu. Uh, Roughly 10 minutes to go over teaser, which I prepare for you to have a tips like maybe to jump into introduction to your management, what can be done with the graph, basically, and Sapphire queries to protect your systems. And then we have roughly 10 minutes about like wrapping up, getting your feedbacks and discussing what else can be there because Chagu is becoming like the protocol, the idea. Hi guys. Hi everyone. So what is Chagu? Chagu is graph-powered defense for agentic AI. Chagu models like LLM interaction, suspicious flows, and behavioral shifts through predictable monitoring. We're using Genesis block, graph structure, and real-time anomaly capturing. We're using Sapphire-based analytics, and we will go over several examples how we do it. With trace and prompt execution and any different anomalies. Basically, key ideas in Chagu is predictable monitoring, Genesis block usage like it's immutable, and we can trace the transaction and really follow through what's happening. It's a graph structure, it's a Cypher queries, and it's blueprint of defense. So basically, through the moment the tunnel is really connected to our system, we can track what's going on with our agentic frameworks. And basically, I want to discuss why we're using the graphs and what's the initial problem. Right now, agentic AI systems are very chaotic and becoming multi-agentic frameworks, becoming like ensembles. It's hard to trace prompt. It's hard to see hidden interactions, and it's hard to detect the drifts. Traditional logs, JSONs, they don't show the relationship, and basically graphs lets us to visualize the problem and to see right away what goes wrong to classify the node in this sector or that sector. So how we think about security? Graph-based defense protocol, like for generative AI, we're building the node. Node for us, it's a prompts, responses, user, and models, which was following through these prompts. So relationship for us is like who responded to whom, who requested by what, and what we generated. This basically all the system is detecting also state drift, suspicious flow, and we're using Neo4j, of course, to represent prompts and to see our nodes. And later we all will see that as well. So how detection drift happening is basically we have Sapphire query, which matching like this example prompt generated to response, and this tracks connects changes between prompt versions, measures semantic distance between expected and real responses, and we're using Sapphire to query anomalies. What is a little bit about our architectures and component responsibilities? Like we have LLM live event stream, raw prompts, responses, tool calls, trace IDs, preliminary model scores. ingestions in feature pipeline, it's normalization, reduct PAI, building rolling features per user rate, entropy, novelty, generate embeddings maps to graph schema, very nice stuff, which helps us to identify where query is malicious or not. We're storing it in Neo4j. First class entities, it's user session prompts, tool call resources, alerts, relationship. What is done, what was happening with transaction, what was sent next in Vox, and what was targeting. We're also building vectors and doc indexes, It's fast semantic search. We are finding the similar prompt and we connect it drift behavior and personal history from that endpoint on this endpoint. So our detection agent is hybrid. It's natural intent classifier like Exify, jailbreak, prefix, autoencoders, one class for, we're using it basically for novelty and embedding drifts. Cypher rules, it's like pattern, sequence, temporal logic we can bring into the query, and like with the beginning, the malicious drift, why we think it's malicious, and we're trying to sanitize it and track and understand literal movement and what can it be. It can be escalation, like gain sensitive information. It can be model tricks here and there. We also do GDS analytics. It's like shortest path, key steps, neighborhood, communities, and centrality for graph native anomalies. And fusion, it's where there is scores when we are getting something like unexpected, alerting the risks. Of course, all of this couldn't be possible without visualization layer. So we're using Bloom, GraphXX, representative storyboards, analytic timelines. Chagu is alert intent system. So we are doing webhooks, Slack notification. Of course, we can't avoid pager duties, any policy enforcement, rule-based. And observability, more metrics we can extract, the more we understand what's happening within the system. So our example of use cases, it's our LLM used for multi-agent content generation. For example, one agent starts producing off-policy responses or weird behaviors. We have the main agent that is like monitoring the track of the consistent behavior of the agent. And if something goes wrong, we're getting alert and human being comes in the picture to see what's going on. We also visualize like the drift nodes in red for us to like actually be on the spot in the right time. So our detecting prompt injections, this is like an example how we do it. For example, some keywords like ignore previous or system overrides, etc., etc. This is like a blueprint. Don't take it literally. It's just like one of the examples how we can identify that something gets wrong with the system or somebody wanna do some malicious in our system. Again, it's tracking content, context, it's measuring semantics, it's we're using Cypher to query anomalies. Great, so I think 10 minutes passed, we can do a workshop time. Basically, I wanted to go over 3 steps first with you, what we want to do, and when we will switch to Kaggle and see how we can execute and represent the nodes, and see what can be done and how it can be visualized. Basically, it's very teasering solution for you to start thinking in that, to think in this direction, and maybe to use and implement it on the fast track in your systems. So we will install Neo4j. We will use graph database. Basically, in Kaggle, I'm using Aurora instance, and that's great that Neo4j is giving us like the opportunity to actually, as a developers, to use a free trial, so we can experiment. And basically, I think that's awesome. For this session, for example, I spin it up. Okay, Harish, sorry guys, I can copy paste like basically the link to Kaggle. I will try to share it with you guys, of course, for you to follow. No problem. I think, guys, we can manage like to follow through. I will paste here into the messaging in a few the Kaggle notebook with the examples for you to follow. The query would be there, everything, the code examples would be there. So please don't worry. In a few, I will share it, okay? So the very last step, we will actually be able to detect the anomaly. So stay with me. I am right away sharing this. Okay, yeah, this notebook. Just a second. It's on. We will do it public, of course. Sorry, guys, for some delays. I'm putting it here, or I'm putting it here. Can you see my link, guys? Okay, perfect. You can see my link. So basically, this presentation I fast-tracked to prepare for you some code examples with the database. It's really small database, but you can follow through and fulfill different examples you're facing with the prompts, etc. Intent score is based on our model hyenas, like they was really trained on the prompt injections. So I took it from the resulting. Then we usually obviously very important that. Then I did like approximation of what can be built here. So we will use, by the way, our Aurora instance, like which is very like for the developer oriented instance. So we connect into that for the query. And yeah, before I already ran it like some queries, but we will do it here as well. So right now, let us execute the stuff. Basically, some works around how to work with the data from like floats, etc. Some stuff. Then basically for the quick metrics, we are required intent scored, anomaly score, score and labeling, which we have here. So then we are building the graph. Then we detecting the drifts. I stick it with the two examples. One example is for your local usage, and the second example basically to register. And yeah, just this is very pretty straightforward demo. Please ignore the authentication because it's a try. Of course, the instance will be closed and nothing can happen. But like the idea is here. If we are running it at all, we are getting like the precision recall F1 score accuracy. We can see how many nodes we built, how many edges. Yeah, sorry for some mistakes there. Need to be pre-workout as well. But basically, what we can say pretty fast, like for example, we can match let's do, like, for example, let's see the privilege escalation, like here. Not so we have 6 word. Oh, sorry, that's intent. Oops. Like let's do this prompt I tested. Sorry, so let's see, like, the malicious prompts which we did here. So we can have information about what was malicious, what's not, what actually the text query was, what is our session ID here, what is our labeling and anomaly scores here, and, like, I think this is basically it. And I can give you like 7 minutes to go over code and maybe to follow through to ask questions, and let's think together. What do you think about this session? And maybe you can give me some more interesting ideas and feedbacks how you using Node4j, and do you think it's, like, really important for visualization and securitization our working processes? So I'm giving the floor to you guys. And maybe in 5 minutes we will summarize what we learned and, like, continue our day with this conference. Basically, what else I wanted to say, which is not covered by slides, is basically how we can visualize the graphs as well. Okay, no, that's not it. Sorry, we will do this button. So we have we can use Neo4j Bloom, we can use Graphics, MemGraphs Labs, Gephi, and I think what is very, very important for us to consider for the future, that our agents will talk to each other, not like in plain query language, but they will use a Gibber protocol. And in this situation, Chagu will be very, very helpful, because right now we are tracking the behavior-driven agentic ways, and we are putting it in our models, and then we are matching them with the Gibber to understand and to track this intent. Yes, of course you can. Just the Harish Joshi, is it right? Please correct me if I'm wrong. Yeah, you have. It's absolutely free version. It's you need to register yourself. I was use my Gmail, and getting started, you're going to the instances, and you can create the instance. And this is like, I can't use free trial because I just use it. There is an options we can do, and also we can use provider and region. And thank you, Mesh. Yeah. So you're clicking next, and basically you're ready with your instance already, which is running. So yeah, basically this here you can connect, here you can explore, like, not everything presents in the free trial, but something we can do. For me, if I need to present some ideas pretty fast, I'm doing query based, whatever you saw right now, like pretty much I'm connecting to the nodes, I'm seeing my prompts, I'm seeing, like, users, I'm seeing what's going on here. Basically, you can go further, like to build 3D graphs with connections. I didn't cover it in this session, but maybe hopefully next time we'll do very advanced techniques on that capturing, but basically what you can see in Chagu is really relation on the nodes and queries and what's going on with the tunneling of request response. Can we use, can we use Neo4j Aurora with AWS? What would be the latency increase? I actually using the Google Cloud, this Aurora, but latency, you need to measure that. Basically, of course, this is networking, right? And how fast your request response will be covered. It's on the infrastructure side. By the internet, it's pretty fast. You need to have the scalable solution and scalable networking solution to provide the scalable traffic to fast rate of response and requested. For example, you can put it on some kind of Kafka-based situation, right, per rate of responses and increase the number of instances. Then Aurora from the side of Neo4j, I think guys can back up me from Neo4j. They're quite scalable and they're really support is very responsive, so they can jump into the call and measure latency with you from their side, but your side you need to cover by yourself. Yes, it can be used. Many customers. Okay, yeah, Umesh, thank you for answering as well here in the thread. Yeah, I think Umesh is also like saying the same thing. Okay, guys, so we are in 5-minute window to wrap this session. Thank you so much for being with me, and that was amazing experience to share the ideas. Please contact me. It's Talex Maxim. I'm on Medium. You can find a little bit more information about Chagu, which I didn't cover here, and especially about the Gibberlink and stuff we're playing with, a little bit more information about our models and how we are actually enhance the security. A new project right now, Chagu is going to academia. So some part of the Chagu will be covered by PhD resource in academical papers. I'm so hoping that this session helped you. From the session going on, I think we can. I will ask our producers to provide them. I think we can. Yeah, I don't want to like answer 100% sure, but oh, thank you very much. Like, yeah, let's connect on LinkedIn, and really it's really amazing stuff, guys, and it's security that a lot of, like, when agentic frameworks popped up. Yeah, for sure, please find me. It's Talex Maxim, like pretty straightforward. Please guys find me and we will continue this discussion further. Yeah, so the security aspect, what I wanted to say, it's really very important in the context of agentic, and it can slip away. For example, the agent can be configured over permissive, or the agent model hallucination, or it can be maliciously, like you train your model on one data and somebody is always sending the request with the slow drift when you can't track. For example, the drift measurements company uses, it's like from 0 to 10, the drift is acceptable. So what is the malicious intent is happening that you're acceptably with this zone, always sending the request with the drift, trying to compromise the model. Oh, yeah. I think maybe it's free trail, then instance creation is slow because yeah, I think it's for free trial only, but we always can complain to support. I think they have contacts there, like pretty accessible, like um, somewhere in getting started. Somewhere I saw like contact support, um, community support. Yeah, so we can complain there if we need some. Something from the support we can ask. Basically, like, guys, 3 years I'm in the hackathons with Node4j. Basically, yeah, we do demoing, but the guy, the support team and the overall all team is very supportive, and they provide us with tools and question answer. They're very responsive. So you can write if you have, like, for example, some hackathon project, like, hey, I want to show and I need something. Yeah, exactly. Yeah, local version is the same. I just wanted you to have like both ideas, maybe locally on the house, like exactly you can cope with the smaller latency there. Yes. And basically, what I also want to invite you guys to collaborate on cybersecurity for some patterns and some kind of weird behavior you can. Oh my God, guys, thank you so much as well. It was enjoyable, and have a great continuation of the day. And yeah, please find me on LinkedIn and we can continue this discussion.